Hi everyone, I'm Martin and welcome to another great edition of Astronomy for Beginners. And today we're going to do a very unique guide, a particular video guide which you'll find that it's not even on the internet at all. No matter where you look into it, no matter where you find it, there is no live guide based on collimating a Maksutov category. Now, there's a lot of people are very concerned about owning a scope like this, is because it provides, the telescope provides fantastic razor sharp images that are almost near to none, almost to an apochromatic refractor. With colour-free images and razor sharp images is what you need for looking at the planets and the moon. And because it's a longer focal length, it's ideally suited for higher magnification, and it's a terrific planetary scope. There's no other scope that you can get for a lot less cheaper than an apochromatic. I mean, this 5-inch Maksutov here that I have here, is fraction of the price compared to a 4-inch triplet refractor, which is, I mean, this costs around about £300 just for the tube, and then you've got the mount and all that sort of thing. But for optical performance, the aperture, the longer focal length, the magnification it offers, the light gathering, you cannot beat it for the price. The Maksutov wins big. Okay, there's a fair few minor problems with the Mac. It's got a narrow field of view, and also it's a dual magnet. In other words, it will attract moisture, so you need some form of dew shield to try and protect it. And also, the biggest problem is the cool down. Don't let that concern you for a lot of you guys. The cool down on these scopes, if you let this one particularly let it cool down for about half an hour, it should be more than ample to review, cool down and provide razor sharp images. That myth. Ignore what people say about the cool down period and all that. Just let it settle for about half an hour and you can't go wrong. Okay, bigger the aperture, longer the cool downs. Now, I believe the big brother to this, which is the 180 Mac, basically requires around about 40 to about an hour. But again, what do? You just leave the scope, let it cool down for about an hour, and there you go, you're off the image. Right, what I'm going to cover is, I'm going to dispel this myth that a lot of people, a lot of astronomers are very concerned about, is when they own a scope like this, is the collimation is very crucial. Yes, it is very crucial, but believe me, it's not that difficult. And I'm going to dispel that myth, get rid of it once and for all, and tell you guys that owning a Mac does not have to be a collimation issue. Now, I'm fully aware that Maksutovs have they are renowned to hold their collimation really well. Practically, if you lose collimation, you've basically got to drop this scope. I mean, drop it on the floor and throw off the optics. That's how well it holds its collimation. As time goes by, the Maksutov may lose collimation. What I'm going to do is, I'm going to show you how to collimate the Maksutov, right? And it's not very difficult. In fact, it's very easy to do. You just need a little bit of time and patience to do it. Now, as you see in the lover guide, I demonstrated the Geo-Optic artificial star. Now, this is a variable brightness device which will emit a very accurate LED of about 50 microns or less. And what this does is to simulate a star, as if you're looking at a star. Now, the reason why I bought this device is that this device can be used for collimation for Newtonians, Schmitz, refractors, and also the Mac. Now, believe it or not, the Mac seems more complicated compared to a Schmitz cascade. Now, I've seen over the years that there are loads of video guides on the Cassegrain, the Schmitz Cassegrain, but there's nothing, absolutely nothing on the Maksutov whatsoever. So, being the first video guide to demonstrate to you guys how to do it, alright, using this artificial star. Now I can't stress this enough. I prefer to use this device if I was going to collimate the optics for this scope. Now there are other alternatives to do this, but I found that being a much more effective way to collimate. Plus, once you've bought this device, this will also be very handy to adjust your other telescopes as well. Alright, and what it does is, it does basically, as most astronomers use to star test. Now to star test the optics on the telescopes and all that, see if it's collimated, you have to spend and lose time setting up the telescope and basically focusing on a star and to try and find if it's out of alignment. Now what you got to think about is that you're losing a lot of important precious observing time or imaging time. What this device does is enable you to do it during the day where it's a cloudy moment, cloudy day, or it's raining and all that. This is where this plays dividends. Now you can buy these devices. There's Geoptic and PicoStar. Right, they're the firms that seem to offer these devices, and you can pick them up from about €60 up to about €109. Alright, so it works out round about, for a cheap one, for about £30 to £40. It sounds a lot expensive, but it's usually due to the functions of the artificial star you're going to buy. Now for this one, I got this one because this has a variable brightness, so that I can adjust the brightness. The cheaper ones don't have them, they just have an on and off switch, and that's all it is. But it seems a lot of money for paying for something like this. But however, when you've got it, this will save an absolute, it saves you a lot of precious time and a lot of hassle. Again, I can't say enough about this device. So what we're going to do now is we're going to look at the equipment and tools you're going to need to carry out the collimation on the Mac.
Right, the equipment you're going to need is obviously the Geoptic artificial star, or Pico star if you've got one. So you're going to need that obviously for that. You're also going to need some kind of torch. Now I'll explain later on why we're going to need a torch. You're going to need a 2mm Allen key and a 3mm Allen key. Right, very crucial that you have them too. Now this really depends on your setup, but I found out that you can either use it with a diagonal to do the alignment, or you can extend it or use a Barlow. Now you can use several of these three things. I will see, because I've got limited space, I'm going to use the a star diagonal for this one. A lot of people do not like to use diagonals for collimating the optics, but believe it or not, if you've got a well constructed engineered star diagonal, like high quality star diagonal, it shouldn't be a problem with flexure and all that. So use a good high quality star diagonal. If you don't have a star diagonal, you can always use like a tele extender, right? To a tube extender, so you can get it within focus. Now, the reason why you need extension pieces is that you might not be able to achieve focus within a short distance. So that's why you use a form of a diagonal or a tele extender or a Barlow, so that you can achieve focus. Now don't forget, you're going to use high power. You've got to use at least 100 times magnification to do this star alignment. And it sounds crazy, I know, but you need high power so that you can get your focus into your alignment star. Now you can use any one of these three, but I'm using the mirror diagonal. The Barlow lens is basically an extension tube, but it will also increase the focal length of the telescope, gives you more magnification. However, what that will do is it will reduce the inward focus, and you may be able to get into focus then that tele extender. Now, it's up to you which ones you're going to use. Again, it just depends on the area, and because I've got limited access, I'm going to use the mirror diagonal. And then last of all, you can use series of eyepieces, but I find using the Mach 127 is use a good 10mm plus eyepiece. Right, that's all you need, a 10mm plus eyepiece. Okay, so that's the eyepiece I'm going to use. It just depends on what eyepieces you use, but I wouldn't recommend using wide field eyepieces, to be honest with you. I'll just use a standardised Plossl. Usually you get the 10mm with the 127 Mach anyway as a standard issue. But again, it just depends on what telescope you own, what Maksutov. So what we're going to do now is we're going to go onto the setup. Right, this is what I'm going to explain about these screws. Now, the manual covers the collimation for the Mach, and it's very, very mind-boggling to understand. And you know, it's a full page of the collimation on these bolts, and to be honest, it's not very straightforward. Now, here you have the big ones, which is the 3mm screws. And then these screws here, the smaller ones, are the 2mm Allen bolts. Now, the manual states you have to loosen a few of the big ones and then slacken the other, and vice versa. And it's not very simple to understand. In fact, that I basically scrapped the manual because it's just far too complicated. And even for an experienced astronomer, is that it can be very brain taxing to understand. Now, what I have found out is that the easiest, simplest way to remember, and it's probably the best way to remember, is if you're looking at these bolts here, remember that these bolts here, the big ones here, okay, they screw on to the back of the mirror. Basically, at the back of this tube, at the mirror, there is like a mirror cell which tilts, and basically these Allen bolts here, they screw onto that plate. Now, what that does is that because it screws in there, they are also known as a pull bolt. Remember, it's pulling it together, so that's what these bolts are. So remember, pull. These bolts here, the small one, the small Allen keys, they're like little grub Allen screws, yeah? And what these do is they push against the mirror cell. So in effect, you have got a pushing motion. So remember, the small ones are pushing and the big ones are pulling. It sounds very, very strange, but if you think about it, technically wise, that's what you're starting to achieve. Now, obviously, in the manual, it's far too complex. Now, a word of warning is when you first do the star test, I advise that when you look at the artificial star, I will explain the details on all that. But if it requires collimation, then do it by all means. Basically, slacken these bolts off slightly, and I mean slightly, and then you can do your adjustments on the smaller ones. Now, do not attempt this. If the collimation's fine, leave it alone. There is no requirement to do it, and I will show you the diagram what is a fully collimated Maksutov. If it does require collimation, then yes, do attempt this. Now, Macs are not always known for losing collimation, you know, and they hold the collimation extremely well. But again, with these screws here, when you start filling around and adjusting the main mirror, is that you only require, it's like 1/8 of a turn, maybe at the most a quarter. The big ones tend to do the bigger movements, and the small ones a lot more fine adjustment. But you've got to remember is when you're adjusting the mirror, remember the big ones are pull and the smaller ones are a push. So whatever you do, for example, say like you want to move the mirror to the right. Basically, if I was you, I would loosen the top one here slightly and the top and that one slightly there at the bottom. So these two here, you slacken them off, and then you tighten that one to push, and then you have to slacken these so you can tilt the mirror to the right, and obviously tighten that one. I'll repeat again. If you want to tilt the mirror to the right, you slacken these bolts here, you slacken these two here, you then tighten this one, and then you tighten that one. And it seems very complicated at first, but believe me, it comes with practice. Now, the thing is with the collimation on the Mac is that there is no adjustment for the secondary mirror. So that is one thing to remember when you're collimating the Mac. The secondary mirror is already made, it's a coating, it's onto the mucus lens, and there is no requirement to adjust the secondary. It does take some time to adjust the main mirror, but once you get it right, it will be perfect. Now, these are only small adjustments. Another prior to warning: do not over slacken these screws. If you slacken the big screws too much, what that will do is that this cover here will end up coming loose, and what will happen is that if you see this part here, you see there's like a little O-ring. Now, well, this big O-ring that surrounds it is, if you slacken it far too much, this O-ring will come out, and then basically you made your mirror self far too loose, and it could, you know, it's only minute movements. You do not need to do massive adjustments. You have to do it bits at a time. All right. So if you want to do this left hand side, or you want to adjust the top or bottom, you just got to keep doing it. You know, you got to slacken one screw and tighten the other. So if I'm going to tilt the mirror left, what I would do is you slacken this one, tighten these two depending on the tilt, and loosen that one. Okay, what I found that it was easier is to slightly loosen all three of the big bolts. So loosen all three of the big bolts slightly, and then do your adjustment on the small ones, which I found that easier for me. The manual explains something totally different, and it's telling you a basic sort of guide setup, but it's very hard to understand. So what I found that easier for me is to slacken these bolts slightly, and do minor adjustments by pushing or pulling and tilting the mirror. Remember the process that these bolts is, if you want to slacken it should be you turn it lefty loosey to slacken, and to tighten is righty tighty. It sounds like a nursery rhyme at first for children to remember, but believe me, it helps a lot of you guys and myself. Remember, lefty loosey, righty tighty. Alright, and you can't go wrong with that, and that gives you an inkling on where you're going to turn and where you're going to tighten. Okay, so what I do is I always slacken these ones slightly, only quarter of a turn, and that is it. And then you just basically tighten up or loosen to adjust the angle of the mirror, and that's the easiest way that I think you can remember. Once you got that set up, then you can slightly tighten these up slowly, gradually, but you've got to keep checking on the artificial star, see if it's centralized in the eyepiece, and just keep looking till you see any changes on the circle patterns. If there is, then you've got to keep doing it until those circle patterns are parallel and nicely rounded, and it's perfectly round. Alright, and that's the adjustment. What we're going to do now, we're going to go over to the setup and show you now.
So, for the basic setup of getting your telescope ready for the collimation on the artificial star, refer to the manual. On the manual itself, it states that to adjust the collimation, you've got to have the artificial star to be within a certain distance. Now, I worked it out for this scope, it's around about 11 meters for the artificial star to bring this telescope into focus. This can be achievable indoors if you've got big enough space. Luckily for me, I have actually got just 11 meters in my apartment. Basically, I've got the room that's adjacent to the nearest to the furthest bedroom, and I can now place my artificial star. Certain precautions you need to undertake is use the motor drive on the go-to if you've got it, or use slow motion controls. Using the power tank, whatever you've got to power it, is use slow motion up and down, all that, so you can get the telescope in alignment with the artificial star. You need to try and get it central within the eyepiece. Also to remember is, don't use, if you can, don't use a finder scope, because you might not be able to achieve focus because the target is so close, is that you might not be able to be able to see it. Now the top tip is, I would recommend using a red dot finder. Red dot finder will be big for this, and get it properly aligned within the telescope tube itself, because this needs to be spot on accurate. And the reason why I say that is that you need to get this spot on in line so that you can find it, or you'll be spending a long time trying to find the artificial star, which sounds crazy even though it's indoors and it's not actually looking at a sky. If this is not aligned, you're going to be wasting a lot of time setting it up, trying to figure out where it is. Once you're within, you looked at the book and it's in the right distance, you measure across how far at the telescope mount all the way down, the required distance is needed for the artificial star to be positioned. For me, because of my limited space, I'm going to just use, you can do several methods. You can use the mirror diagonal, and you just slot that in place like so. Now it's very crucial with any optical devices is make sure that all the thumb screws on your mirror diagonal are very well secured, including the eyepiece. You put on the eyepiece like so, right? Make sure it's all flush and everything's tight, because you don't want any flexure, because if you get flexure in your optical train, is that what you're going to do is you're going to affect the collimation. The collimation will be slightly wrong. Now if you don't have a mirror diagonal, there are alternatives. You can just simply, if you take this, the mirror diagonal part, put in the 1.25" adapter, get a Barlow, get your 10mm eyepiece, slot it in place like so, and then fit it like that. Okay, so you could do it that method as well, but it just depends on how far the artificial star is to enable you to achieve focus. Can be a bit tricky, but will reduce that limited amount of inward focus. Again, it's high powers. Try and use high powers. A minimum of 100 times is required. I mean, you can use just the eyepiece on its own, but it might not go into focus. There might not be a lot of inward travel. Again, you can use tele-extension tubes and then slit it in there and so forth. But it just depends on how you want to use it. For me, because I've got limited amount of space, and I'm literally this telescope is going to go far close to this door here, and so that's how far I've got to get my distance. So I have to use, unfortunately, the mirror diagonal, but it's high quality mirror diagonal, and there's no flexure in there at all. It's quite sturdy, so that's what I'm going to use. It doesn't really matter which process you're going to use. They both work. Just provide that you've got no free play at all within your image train. So now let's go over to the artificial star setup.
Now we're at the artificial star setup. I've basically got my artificial star switched on. I've adjusted the brightness on the knob so it's at the correct sort of brightness and need. During the day you need to just make the brightness just a little bit brighter, and I've got a red torch here. Now the reasons why I've placed a red torch is that the artificial star is extremely dim, and at first time when you're trying to adjust move the telescope in line into the field of view of the eyepiece, is that the artificial star might not be there. So what I do is I use the red torch and align the red dot finder to the red torch, and then hopefully it should be within my eyepiece. If it's out of focus, you'll know exactly where to focus. Focus the red torch light, and then once you've achieved focus, then use the red dot finder and then align it up to the artificial star, and then it's the easiest way to do it. Now, have you noticed I've got a laundry basket on there, and I've got a stainless steel pan, and basically what I've done is I've achieved it. You need to get it from the telescope to there, sort of the right sort of height distance. So basically the telescope tube is at 0 degrees. I don't think it's highly required to get it level, but it's just a peace of mind. It makes just the alignment just a little bit accurate. Once you've got your setup ready and your red dot finder is on, what you do is you will move the telescope in position in the correct distance as stated from between the artificial star and the telescope leg, for example. Now this is the manual, and it's got different types of apertures, and it tells you the sort of distance you're looking at. Because it's 127mm, we're looking around about 11 meters. So basically, from the telescope all the way down to the far side of the bedroom, the spare bedroom. So obviously we're going to over to the telescope, and we're going to basically move the telescope. So basically what you do is then you switch it on, and then we're just going to use the red dot finder, look through it, and then centralize to the red torch and then focus. Okay, we've lined the red dot finder onto the main red torch, and then basically after we moved it in position with the telescope, we're then going to focus on the telescope tube itself. So as you can see, you adjust the focus. You don't have to be perfect, but basically what I'll do now is we'll give it the sharpest view, so that now what we're going to do is we're going to move the telescope to the artificial star. So then what we're going to do, go over to the red dot finder, you might have to adjust the speeds slightly so that you can get it. Take some time, but using the directional keys we should be now be in the view of the artificial finder. We're on the artificial star, and you can see it's focused. So what we're trying to do is put it out of focus. And you put it out of focus in a way that you will start to see rings. You can see all the rings. What you're looking at is you've got to look at those rings, see if they're all rounded, and you can see that the central mirror is slightly off center, and it's only slight, very, very slight. So then what we'll have to do is basically from there adjust those screws so that you need to get that central dot bit central as possible. As you see, it's slightly out, not much, but it's slightly out, and you can see it's almost there, the alignment, but you just need to get it just slightly adjusted.
Okay everyone, this is a good description of a example of a fully collimated Maksutov, and a Maksutov which is out of collimation. As you can see for yourself, you're looking at an out of focus image of the artificial star, and you can see all the ringlets here. That will give you a good indication of that Mac perfectly collimated. Here is a really good example of a badly collimated Maksutov. As you can see, the secondary mirror is slightly off centre, and all the ringlets all around here are all sort of ovaled, and that's a good indication that the Maksutov needs to be collimated. If you look at your Maksutov and it's like that, it is time to adjust it. I thought this a good example to show you guys and girls, to show you a good example of when a Maksutov requires collimation.
Now this seems stupid, but I found out when you're looking through the eyepiece and all that, top tip is use a pen or some pointer and basically look through the eyepiece, like so, look through the eyepiece, and then using a pen just jiggle it in front of the objective lens. You know, be careful not to touch it or scratch the objective lens, and just wiggle it around. And what you're doing is you'll see a protruding pattern or shadow across around that circle, and you just do that so you orientate yourself, so you know which screws where you need to adjust. Alright, and you can differentiate what's top, what's bottom, left and right. Okay, using the bowler lens method will probably give you an upright vision, I don't know. But I can't use that method. I have to use the mirror diagonal. So I have to jiggle it around and orientate myself. You see a needle on there, and I'll show you now. Okay, so what we're going to do now, we'll jiggle that pen. As you can see, that's the top. So I'm jiggling it on the top. See the bit that sticks out? I'm going to do it to the sides. That is my right hand side. This is my left hand side. And this is my bottom. Alright, and basically what it does is orientates you where to go. Alright, it sounds stupid, but it will actually help you adjust the which screws and orientate it that way. Now as you can see, it needs a slight adjustment. So what we're going to do now, we're going to adjust the collimation.
So this is what we're going to do. Using the 2mm and 3mm Allen key, you slightly slacken the big bolts all the way around, like so. So lefty loosey. Okay. Then you look through the eyepiece. And what we do is, because it's slightly out, what I need to do is I need to try and tilt the mirror to the left. So basically, the two main bolts here, I slacken the small bolt on this side. You can't see it there. Then I tighten the small screw. Then I move, just check the artificial star. I place it in field of view. Okay, I place it in the field of view. So I keep adjusting it so it's central to the eyepiece. I check again. And there you have it. Basically what I've done, I tighten this one up. I slacken these on this side, and what that's done is tilting the mirror on the left hand side, which was slightly out. It is trial and error. You have to keep adjusting it till you get it right, but make sure do not loosen those bolts too loose. Do not loosen them far too much, because it'll be absolute nightmare to try and get it back. So bit by bit at a time. Alright, so basically what I've done, those are loose, I just tighten up, checking, okay, and they're only finger tight, literally just finger tight, enough tension, right, that's the main ones done, alright, check again, see if it's central. Okay. I only have to do a slight adjustment to that, and what I'm going to do now, I'm going to show you what you're trying to achieve. Again, it's so easy to do. You just need a bit of time and patience, and just carefully do it bit by bit. Now, each of these adjustments is a tiny amount. So what I'm going to do now, I'm going to show you what you're trying to achieve.
Now, as you can see, the rings are a lot tighter now, and the central obstruction is more or less centered. Probably I need to adjust it slightly bit more, but it just shows you that these minute movements on the Allen screws do massive adjustments, so you've got to be very, very careful. To be honest, I would do a little bit more of adjustment on that, slightly more to the left, but I'm actually quite happy with the results. But what will happen is, if the collimation was out, those rings will not be round. They'll be like an oval, like an egg shape, and the central obstruction will be slightly off as well. So, but that's what you're trying to achieve: a perfect circle, and obviously the central obstruction is in the middle. Alright, you're not going to get totally perfect, but the whole idea is to show you guys that collimation is very crucial on this. But take your time, little bit by bit, and again, using the artificial star. If it requires a collimation, and you can tell if it does. If it does, then do it. If not, I mean, you can get away with that. That's perfectly fine. You can see all the little ringlets, as if we adjust the focus a bit more. Okay, you can see the circles now. They're a lot more rounded, and you see the little ringlets. That's the sort of thing. Now, the camera's not doing any justice here, but it actually is more or less centre. It's just where I'm angled the lens on there. It's giving the effect it's slightly out, but it's actually perfectly aligned. So, again, I might need to do a slight adjustment, but it just proves that you can actually collimate a Mac using the artificial star method. Alright, and this is probably going to be the best method to do on any Mac. And again, that should serve it. That should hold the collimation for years to come. Right, everyone. This is a snapshot of my Maksutov fully collimated. The reason why I've done this picture is to illustrate a perfectly collimated Maksutov. Obviously, the camera hasn't done any justice to show it clearly, so I thought it was a good idea to post this image so that you can see how perfect the collimation is now. Something to bear in mind, as well as the ringlets and the central obstruction being centre, also a good indication is right in the middle there'll be like a tiny star dot in the middle. That's also a really good indication that all your mirrors and the lenses are all fully aligned perfectly, and especially if you get that central star in the middle, which I'm actually quite impressed that it's actually my Maksutov is now finally sorted out.
So that concludes my video guide on collimating the Maksutov. Useful tips to remember. Get the set distance correct to the aperture. Using the 10mm eyepiece, doesn't matter if you're using a mirror diagonal or extension tube or ball method. Making sure that your finder scope's aligned, or your red dot finder's aligned, so you can find the artificial star. Orientate what is top, bottom, left and right. Okay, it might be different using the mirror, or it might be different using the extension or the ball method. Remember to use high magnification, because you need it to do the adjustment. So 100 times is minimum to do the achievement on. Then remember, once you align it central to the artificial star, remember that the big bolts are the pulling bolts and the small bolts are the jacking bolts or the pushing bolts. And remember the little saying that I always say, bit of a nursery rhyme, it sounds babyish, but it does help you. Lefty loosey, righty tighty. So when you turn those screws, you know you're orientating yourself and visualize yourself how the mirror tilts back and forth. And also remember, on the Maksutov there is no requirement to adjust the secondary mirror because it's a compound lens and the central mirror is actually plated onto the element itself. There is no requirement to adjust this part, only the back mirror that goes out of alignment. Hence the reason why Maksutovs tend to hold the collimation, because there's only one certain part to adjust and it is the main mirror. Everything else, it's all in line. It's all manufactured in a way that is perfectly in line with the main mirror. Again, recenter using the handset into the field of view and do the alignment again. Top tip, never achieve this process unless the Maksutov is generally out of alignment. And I mean, if it does require collimation, then do it by all means. It sounds, do not be so go too more in depth on it, but slight adjustments is only needed to adjust it. If it requires it, it requires it. Don't just attempt collimating if the optics are perfectly aligned, right? Best advice is, if it's working fine, then don't fix it. That's my best advice. If it's already collimated, leave it well alone. No need to adjust the screws and all that. But if it does, then by all means adjust it. It is required. But I hope this guide helped you a lot. It certainly has been a big experience for me to undertake such a task. But I've now demonstrated that it is possible to collimate a Maksutov. Now this is only just based on the Skywatcher series, but it's a similar sort of setup on the Orion scopes, the Orion telescope scopes, and the Celestron types. Any others Maksutov makes, I don't know, but the setup for these will cover the 90mm to the 127 and the big brothers, the 150 and the 180 variants as well. They're all the same sort of layout, the same sort of structure, they work all practically the same. Obviously other models, it just depends, you know, on the manufacturer, but mainly this works for Celestron, Skywatcher and Orion telescopes only. I hope you got a lot of information from this guide. Please feel free to comment on this guide, and we look forward to another guide. So thanks again, thanks for watching, and clear skies.